flip lesson for the next part of the notes. So what we're going to do is first I'm going to go over the top part of your notes. Your mole map is here, but I'm going to give you a copy of your mole map in order to go through it together, and we'll fill it out together. So first, if you would like to do these notes on Google Classroom, we will go for page 2 and not do page 3. But if you'd like to do the posted notes on this post as well, you may do that as well. Just look over them if you want. But the thing I need you to know more than anything, 1 mole of any substance is represented by 6.02 times 10 to the 23rd, and that is the Avogadro's number. Remember, Avogadro. He is the one who made this number. This represents the number of particles, so representative particles. If you look at the second thing, we are looking at 1 mole of any substance has a mass equal to its molar mass. So the thing we talked about on Monday, we need to make sure we know molar mass. A molar mass is, so 1 mole of any gas at STP occupies a volume of 22.4 liters. So we have our Avogadro's number for the representative particles. We have whatever the molar mass is, so that would be one that we have to calculate like we did on Monday. And then we have, which is always going to be in grams, and then we have our volume is always equal to 22.4. So our mole map is represented right here. Oh, one other thing. STP is 0 degrees Celsius and 1 atm. So remember, that's standard. That's your standard gas comparison. All right, so mole map here. You are more than welcome to draw the next part on your notes, but remember, you will have to have this as finished by today, or today for sure, because this will be what we are going to have to laminate. So you'll finish this, you'll give it to me, you'll laminate it, you'll do your practice problems today. I will laminate it for you before I leave today, so that way we can get it going. So go ahead and get out your mole map that we have. So first thing we have to do, our mole is our middle ground. This is the middle ground for everything. So we're looking at number of particles. That will be whatever the number is. And remember, if we're going from a mole to our particles, we are always going to multiply this number by 6.02 times 10 to the 23rd. If we're going from particles to mole, it's just the opposite. So when we're going this way, it is our number divided by 6.02 times 10 to the 23rd. Remember, this is your representative particles, like said in the notes. So 1 mole for your representative particles equals Avogadro's number. Moving on. So if we're going from mole, our next thing was, we can go either side, but we'll go right side because I'm right-handed. It'll just make it easier. So we will go mass. So mass is always going to be in grams, because you're never doing a large scale experiment when we're here, so it'll always be in grams. So grams is always going to be, when we're going from mole to grams, we are going to multiply our molar mass. And if we are going to moles from molar mass, we are always dividing our molar mass. Alright, makes sense? Whatever number we're looking for. So, if we go into this, so last thing we have left, we're going to get our volume. So our volume is in liters. We will, when we're going from moles to volume, it will be times 22.4 liters. And if we are headed back to moles, we just divide by 22.4 liters. Make sense? Okay. So now that we have our molar map, this will be what you can use to remember. So if we're looking at 5 moles, we'll just use this as an example. So 5 moles equals how many liters? So we do 5, it'll be equals blank liters. You do 5 times 22.4, and we get our answer of 112 liters. So that's just an example of that. If we're going from representative particles, you always do this. If you're going for molar mass, you figure out whatever your molar mass is to find the number of moles, or you find the molar mass based on the number of moles. All right, makes sense? So if we have 3 moles, we multiply that. So if it's H2, if we have H2, that's going to equal 2 times 1. So our molar mass is 2 grams. And in order to, so say we have 5 moles of H2, that equals 5 times 2. So we have 10 grams of hydrogen in that case. So volume goes up here, and then representative particles, you always multiply those by the bigger one. So we're not going to do a sample that, except for on the notes. So if we look on the notes, you have blank number of moles equals this many atoms of P. So based on our understanding, we're looking for moles. So we're going from the particles to moles. So you would take this number, 1.20 times 10 to the 25th, and divide it by 6.02 times 10 to the 23rd. You're more than welcome to do your math here, or you can just easily divide it. So remember, 1.2 times, divided by 6.02 equals. So this is going to be equal to, remember when we're subtracting exponents, you have 0.9199 times 10 to the second. But remember, we can't do that, so we have to move the decimal place over 1. So that's going to make this equal to 1.99 times 10 to the 1. So, or 19.9 moles of P. Pretty simple, if it makes sense. So there's your practice problem for your atoms to moles. So now we're looking for moles to atoms. So you have 0.750 moles. So you're going to multiply that by Avogadro's number to the 23rd. Because remember, we're going here. If we're going from moles to particles, you always multiply by this number. So when we do that, we do we'll clear that out, 0.75 times 6.06 or 02 equals. So this number is going to equal 4.52. Remember, because we're only doing 3 sig figs, times 10 to the 23rd atoms of zinc. Make sense? All right, we will go. If you are having trouble with this, you are more than welcome to ask questions. If you are not, go ahead and grab the worksheet that goes with this, the practice problems that we're going to do with this, and then you will get started on that, finish it, no worries. The biggest thing I want you to do today, make sure you get this mold map done. It needs to be finished and turned into me. All right, this is the important part. If you want to write down the examples so you remember, you're more than welcome to. If you want to put one of these examples on there so you remember how to do it, you're more than welcome to. But the thing that you must have is this. This will be part of your things that you get to use on your tests for the rest of the year. It's very important. All right, good luck.